the recording. I've started the recording for the session. And thank you again, guys, who have joined us. And we are great to have you join the session. We've been having these sessions from session 1. We are now on session 9, just a platform to share knowledge on IPRAN technology. And I know maybe there are some of you who are joining us for the first time. Maybe you can say hi to the team. If you don't mind, you can just open your mic and say hi to the team. Let us know what you're doing, what you are working on, which company you are working for, which networking challenges you're facing, so that we learn from each other. Anyone who is joining us for the first time, or even maybe you've been joining these sessions and you want to say hi to the team, you are also welcome to say hi. It has been a long time. I think we had the last session almost 1 month ago. And sometimes, yeah, so many other things come in and then we delay some of the sessions. So the floor is open. Anyone who wants to say hi, to introduce themselves to the rest of the team. I know majority of you have already interacted. Olayemi, Aaron, Nixon, and many others. We've already interacted on different occasions. But again, guys, say hi to the team, especially if you're joining us for the first time.
There is Michelle Martin. Let's let Michelle first say something.
I see Innocent has opened his mic.
Oh, I wanted to say something, but maybe let Michelle come first.
No. You go ahead. Michelle.
Ladies first. Ladies first.
Yeah, that's what I was thinking, but she's quiet.
Okay, then it's ladies first.
Yeah,
Michelle, welcome and say
she
hi to
opened.
the
She
team.
opened her mic. She opened
Okay.
the mic. Let her talk.
Hi everyone.
Hello.
My name is Michelle. It's not my first time. It's not my first time joining. That's why I didn't unmute. But yes, my name is Michelle Chentai. Martin, what else did you say?
Maybe the company you're working at, maybe the challenges you're facing, so that we also get to know more about you.
I'm currently an instructor at Huawei. I also recently sat for my ATIE Datacom. Yeah, I think that's it. Yeah.
Michelle, congratulations. Hope you've passed.
Thank you.
We have so now we're looking for other HCIs to solve a problem we have, Michelle, from our last session. Now can we count on you also? We have a big problem.
Thanks, Michelle,
Okay,
for joining,
okay.
and yeah,
All right.
we're looking forward to getting the solution to our last session's problem from you. We had some challenges, we had some loop issue.
Okay.
If it
Yeah,
was a live network, we would all be fired. So
that's true, because it's like 1.5 months you haven't solved the issue. You should be fired. Okay, thanks, Michelle. Innocent, my popo.
Yeah, Martin. Hello, team.
Hello.
Okay, my name is Innocent Moipopo. A few days ago, I was a student at the University of Dodoma, and I was here. I'm not new. I'm not new, but I missed some sessions. At the end of the university, there are a lot of exams, yeah, and such stuff like that. But after completing the studies, I joined the Huawei team immediately, and now I'm working at network planning and optimization department. So yeah, currently I'm doing the DT loot drawing. I'm drawing a lot of the drive test loads, but actually I enjoy the IPRAN. That's why I'm right here right now. Yeah, that's it.
Thank you, the new engineers in town. Congratulations on
Thank
the
you.
graduation and the new job opportunity that you have at Huawei. Hope we
Yeah,
continue
thank you.
sharing
Thank you.
knowledge from drive tests to from network optimization. We are also open to learning from other domains. Anyone else? Anyone else who has something to say before we start our session? Anyone else joining us for the first time? Clement?
Hi everyone.
Yes, Clement. Hi.
Yes, so I'm Clement Odanga. I recently finished my school from University of Nairobi, and currently I'm a management trainee at Huawei. So I've been following the IP run, but not on the live sessions, but on the recordings that you have been sharing on YouTube. So I have done so far. I've done this SAP Datacom, and I'm looking forward to probably maybe doing SAE at the end of the year or next year. Yes.
That's great. Congratulations on the graduation and the HMTP. I also started as HMTP actually at Huawei some few years ago. And Aaron, I think Clement should be one of the people we are depending on because
Yeah, exactly.
he should help us fix our problem. So I think we should be sorted in the next 1 week.
Yeah, we have the crew around.
Anyone else? The last person before we start our session today? Okay, so I will assume there is no one else. Allow me to share my screen and start the session. I hope I'm loud and clear.
Yes, you're clear.
Okay, thank you. So today we are discussing deployment of layer 2 VPN services on IPRAN network. So if you remember where we started from the basic IPRAN architecture, from which nodes you expect from the radio access network to the core network to the access network, the different devices that you expect to find in IPRAN network, the CSGs, ASGs, RSGs, and the role they play in the network. We also discussed the different devices, like the device types, which Huawei devices you can use in a network, which Nokia devices you can use in a network. And then we moved to the IP address design. Just 1 minute. We moved on and discussed about the IP address design, the different type of IP addresses that you require, even from the point to point, the management IP address, and some of the best practices that you need to follow when you are designing IP addressing system for the IPRAN network. We also discussed about IGP, the interior gateway protocols, because remember, when you are deploying a network, you need reachability from different sections of the network. And before you go ahead and deploy protocols like BGP, because you will be using the loopback IP addresses, so you need to ensure that you have reachability in your network. And that's where we discussed about the protocol, the IGP protocol design using ISIS. We discussed different best practices that you need to follow, from the closing of the rings, dividing the network into different rings, into different IGP processes. And we also went ahead and discussed on the configuration. So we did a lab on how to deploy, how to configure, how to troubleshoot ISIS on IPRAN network. We then went ahead and discussed about BGP. So remember, BGP plays a very important role on the network, not just IPRAN network, even in the IP core, even in other small networks, we still have BGP deployed on those networks. So we discussed on the design principles of BGP, and we went ahead to discuss about the configuration and troubleshooting of BGP protocol on IPRAN network. We then discussed about MPLS, why you need MPLS on the network to help you to be able to shift from the traditional way of forwarding, and also to be able to use the same existing infrastructure to deploy different types of services. And finally, in the last session, we discussed about deploying the mobile services like the 2G, 3G, 4G, and 5G services on the service provider networks. We discussed about the route targets, route distinguishers, VPNs, and all those different things that you need to configure and troubleshoot when you are deploying services on the IPRAN network. So in this session, we are focusing on deploying layer 2 VPN services on IPRAN network. So of course, layer 2 services, the primary function or the primary use cases of using layer 2 VPN services is when you are deploying enterprise services. So of course, when we talked about the mobile services, we are using layer 3 VPN. Now we need to focus on how you deploy these enterprise services using L2VPN on the IPRAN network. So this is the topic of today, and I hope we will have meaningful interactions throughout the session, just so that we get to share knowledge, exchange knowledge, and learn from each other during the session. So to start with, we need to have some discussion on just some few things, some few topics of interest before we dive deep into the layer 2 VPNs. And the first question is, why do we need VPNs on service provider networks? Why do we need VPNs on service provider networks? Can we deploy service provider networks without VPN? What is the need of deploying VPNs on the service provider networks? Anyone can unmute and comment, because we already discussed about it in our previous session, so I hope this one will be easy for all of us. You can unmute, guys.
Yeah, hello.
Hello.
Good day, everyone.
A good day.
So basically, is to be able to use the same infrastructure to carry many services, like have like you are segregating the router into sub routing tables. We're using route distinguisher to separate different customer edge service from one another. Having the same routers will be able to carry different routing table basically for different services without interacting. And if there's a need to for intercommunication from one VPN to another or from one customer, then maybe the route target will be used to import and export traffic.
Okay, thank you. That's very true. Anyone else with a different opinion or an addition before we move to the next topic of discussion?
Hello.
Hello.
Yeah, so we also need VPNs for the security and privacy of the traffic that traverses the network, since it's a shared network.
Okay, yes. So we have the security aspect that is coming in when we are using VPN. That's very true. Last person.
Also, for extending the network through the internet. Okay, you see MPLS network and all that. While you are accessing a given network as if you are in the locality. So you extend, yeah. So LVPN level 2, layer 2 is used to extend that layer 2 network from one network to another through, which is of course through the internet.
Okay, thank you. So those are the different reasons why we need VPNs, not just layer 2 VPN, but both layer 2 VPNs and layer 3 VPNs on the service provider networks like the IPRAN network that we are discussing about. The next topic that we need to discuss is, so you know that we have layer 2 VPNs and layer 3 VPNs. So what are the difference between layer 2 VPN and layer 3 VPN? What are the differences between these two types of VPN?
So, hello. So one of the differences is that for layer 3 VPN, you are doing IP routing with the customer edge or the customer. While for L2 VPN is like you are just providing a tunnel, a layer 2 L2 circuit for customer can do the routing at their end. So like the L2 tunnel is not what you are creating. L2 tunnel, you are not actually seeing what customer is passing through the traffic. Or yeah, so customer can do their routing end to end while you just provide a circuit, a tunnel over the service provider network.
Okay, thank you. Any?
And
Yes,
uh,
yes.
so I wanted to say for L3 VPN, there is the route RD route target and all that that used to participate in the traffic routing.
Okay. Anyone else? Fabian, I saw you were raising your hand. You have anything to add? Or anyone else with anything else to add on top of what has been said?
Uh, Okay, hello.
Yes, Fabian.
Yeah, basically, good afternoon, all.
Good afternoon.
Yeah, basically, the difference between this layer 2 VPN and layer 3 VPN is that for layer 2 VPN, the customer is in charge of his routing table as his IPs. But for layer 3 VPN, the service provider is in charge of the customer's routing table, IP addresses, and all whatnot. So these are just the basic difference between two of them.
Okay,
Thank you.
thank you. And then the third topic of discussion is what are the different types of layer 2 VPNs that you've come across or you've deployed in your network, and which ones do you prefer, and for which use cases maybe. But this one, let's just mention the type. I think the next one focuses on the use cases for layer 2 VPNs on service provider networks. So what are the different types or the common types of layer 2 VPNs that you've come across?
So there is VPWS, Virtual Private Wire Service, and there is VLL, Virtual LAN. Okay, VLL. I can't remember the full meaning now.
Okay. Anyone else?
Yes.
There's also VPLS, that's the virtual private LAN service
There is a
for
VPLS. Okay.
point to multi-point and then multi-point to multi-point services.
Okay. Any other different types of layer 2 VPN that you've come across?
Have we talked about EVPN?
Not yet.
Yeah, that's also layer 2, right?
Yes, so we also have the EVPN, the Ethernet VPN. That is also, of course, that one it's always kind of a mixture, both L2 VPN and L3 VPN. So it depends with how you want it to work. You can either configure it as L2 VPN or you can also configure it as L3 VPN depending on the application. Any other different types of L2 VPN that you've come across? Of course, those are the common types, but of course they come in different versions. They come in different variants. Like the VPWS, you'll find that they are different. There are also subcategories of VPWS. So the last question is, what are the common use cases of L2 VPN on service provider networks? Some common use cases of L2 VPNs. Why are you using L2 VPNs on your network, and what are you using them for?
Yeah. So one of the reasons is the for to carry enterprise services like you want to teach us today,
Yes.
because the enterprise customer, so to speak, may not want you to see the traffic. They want it a kind of secured to them. Like if you are doing L3 VPN, you're just providing a tunnel, and they want to do their routing themselves without you participating in the routing. You're just providing a transparent pipe for them to route their traffic. So one of the reasons
Yeah,
is
so
this.
that is a very common use case when you're deploying enterprise services for those customers that don't want to exchange their routing information with you, with the service provider networks. Then the best solution is always using the L2 VPNs. Any other use case that you've used in the network?
Martin, so for EVPN,
Yes.
the data center interconnect also.
Yes. So,
Uh,
yeah, you can just finish up.
no, I was just saying that it's mostly we have seen them being used configuring the point of multi-point
Yes, so for
scalable.
the EVPN, you can configure EVPN VXLAN. You know that VXLAN, that is a very common technology, especially in data center networks. So if you want to interconnect different data centers, you can use EVPN VXLAN. So you know that VXLAN, in the pure VXLAN, uses flood and LAN methodology to learn the MAC address, and that is not efficient. So you can introduce EVPN and it will make it more efficient to learn the MAC address. And with the data center interconnect, of course, you are able to even migrate the VMs from one data center to another data center without experiencing any downtime in your network. So those are some of the use cases where you can deploy L2 VPNs on the service provider network. And when we talk about service provider network, this one includes the IPRAN network, it includes the IP core. You can use either of these to deploy all these different types of services depending on where the customer is connecting to your network. So let's look at some common terminologies. When we talk about especially the L2 VPNs, there are some common terminologies that you need to understand. The first one is underlay. So there is always the underlay and overlay network. So when you talk about the underlay, this is the physical network infrastructure that provides basic connectivity between devices. So just that basic setup, the physical setup of your network. The routers, the firewalls, the fiber connecting those different nodes. So this is just providing basic connectivity. So that one we call it the underlay, the physical network infrastructure. And then we have the overlay. So the overlay, this is a virtual network that is built on top of underlay. So the overlay will be built on top of the underlay using technologies like VXLAN. So you are now deploying some services, some virtual kind of setup on your underlay or the physical network. So this one we will call it the overlay network. Then we also have a terminology we normally call the VTEP. Who knows what VTEP stands for? VTEP. What is a VTEP? Anyone who has deployed a VXLAN on their networks?
Is it virtual terminal endpoint?
Yeah, we call it VXLAN. VXLAN terminal or tunnel endpoint actually. VXLAN tunnel endpoint. So this is just a device that acts as a VXLAN endpoint. And the function will be to encapsulate and decapsulate VXLAN packets when they are traversing your network from one, for example, from one data center to another data center. Then you will have these endpoints. Then we have VNI. This is a VXLAN network identifier. Remember, when we are talking about EVPN, of course, we have a version of EVPN VXLAN, or we have the pure VXLAN. So these are some of the terminology that you need to understand when we talk about layer 2 VPN. So we have VNI, which we call a VXLAN network identifier. So that one identifies a VXLAN segment. Then in EVPN, we have EVI. So EVI, this is EVPN instance. So when you are configuring EVPNs, you will have to configure the EVI and ESI. So we have the EVPN instance, which is a logical construct that represents an EVPN domain. And then we have the ESI, Ethernet segment identifier, which will be used for multi-homing scenarios. So remember, EVPN comes in especially when you want to do the multi-homing of active links. Then we have what we call the ESI, Ethernet segment identifier. Then we talked about the route target, RT, which will be used to control route distribution in EVPN and also just normal L3 VPNs. So in EVPN, we also have the route targets and route distinguishers. The route distinguisher will be used to ensure route uniqueness in EVPN. So before, when we are talking about L3 VPNs, we also mentioned about these two items. For the route distinguisher, we mentioned that we have three RD types. Anyone who can remember about the three route distinguisher types that we discussed in our previous session can mention them. What are the three types of route distinguishers? And which one is most preferred?
Type 1, type 2, and type 3. Type 2 is the most preferred, most used.
Okay, anyone else? So for the route distinguishers, we have three types. We have type 0, type 1, and type 2. We don't have type 3. And many times we prefer type 1. So it's type 0, type 1, and type 2. Many times we prefer type 1. You can revisit our previous session on the 3 VPNs and you will get more details about the format of these three route distinguishers. So let's look at L3 VPN versus L2 VPN. So you've mentioned the differences. Of course, when you talk about layer 2 VPNs and you're talking about the OSI model or the TCP IP model. So we know that layer 2 VPN will be operating at the data link layer. But when we talk about L3 VPNs, this is at the network layer. I know you already know about this layer, so we will not go into details. For the functions, a layer 2 VPN will extend a customer's layer 2 network over the service provider's network, making remote sites appear as if they are on the same LAN. This is for L2 VPNs. The function of L3 VPN, it will provide a virtualized IP network over the service provider network. So you are doing IP routing for the L3 VPNs. You are configuring some protocols, like either it could be static, it could be OSPF, it could be BGP, but of course many times we prefer BGP because it gives you the flexibility to control the traffic flow. The customer will be managing the routing and IP addressing. So the customer will be in charge of configuring the routing protocol of their choice and IP addressing for layer 2 VPNs. But when you look at L3 VPNs, that will be for both the customer and the service provider, because the service provider will be configuring a protocol, and if they are configuring a protocol like OSPF on their end, of course the customer also will configure OSPF on their end. So that is a shared responsibility when it comes to routing. So the use cases of L2 VPN, for example, data center interconnect, metro Ethernet services, broadcast domain extension, and we've mentioned things like deploying enterprise services. So those are some use cases of L2 VPNs. Then when you look at the use cases of layer 3 VPNs, for example, inter-branch connectivity, multi-site network connectivities, so you are just introducing IP routing from one branch to another branch, and then you manage those routing between the branches on the service provider networks. Some common examples for L2 VPNs, we have virtual private wire service, we have virtual private LAN service. Of course, we've also mentioned about EVPN, which is the new technology that is now being deployed on many service provider networks. For the layer 3, the most common ones, we have the MPLS VPN. MPLS, BGP, MPLS, IPVPN, or any other version of layer 3 VPN that you could be deploying on your network. And again, you can also have the EVPN on this side deployed as a layer 3 technology. So these are the features for layer 2 VPN and layer 3 VPN. So this is just a summary of the differences between layer 2 and layer 3 VPNs. So when you talk about the OSI model, you have this one operating a data link layer. This one will be operating at layer 3, which is the network layer. For the routing, customer managers. For the routing for the L3 VPN, the service provider will be managing the routing. Addressing, also the customer will be managing the addressing. When it comes to the service for the L3 VPN, we have, remember, if this customer is establishing a connection with you, you need to provide them with an IP address they will configure on their end, and then you establish that connection through the L3 VPN. So for the control, L2 VPN, of course, more control is on the customer. But when you use L3 VPN, where you're exchanging the routing information, there is less control for the customer. Majority of the issues will be handled by the service provider. Because with the L2 VPN, the moment you have your L2 connection up from point A to point B, and you can confirm that connectivity is okay, you've completed your task. You don't need to do anything else. Now, the remaining part is purely on the customer. They have to ensure that the routing, the route control is okay from their end. Because you give them L2 connection here, you give them L2 connection here. So for them, they are directly connected through the, like kind of a list line. And then they should be able to configure the protocols of their choice. They should be able to control the routing information. Use cases we've mentioned, L2 VPN, for example, the data center interconnect, metro Ethernet. For L3 VPN, you can use it for, sometimes, for example, you have the hub and spoke kind of setup. You have the branches, you have the HQ. You can implement communication from HQ to the branches or between the branches through the using layer 3 VPN, like the hub and spoke VPN that you can use to achieve that objective. So for the provider's role, they provide transparent connection. Remember, we are not able to see the traffic that is being carried on these L2 connections. It's transparent to us. We don't care which kind of service you are carrying on this L2 connection. And when you even do a packet capture, for example, if you have multiple hops on this L2VPN and you try to do a packet capture at this point, and this customer is trying just a ping, a simple ping ICMP packet, you won't be able to see those ICMP ping packets. You won't be able to capture any packets on these L2VPN connections. But when you are doing L3, then of course you are providing the routing and forwarding. Now you are able to see the exact information that is being sent from point A to point B on the customer network. So this is the summary of L2VPN versus L3VPN. Any question or any comments, any addition so far? Any question before we move to the next topic of the
Sorry,
day?
my question.
Yes.
My question is, so there's VPLS.
Yes.
So how is it different from VLL or um? There's no term like that. There's VLL, I
Yeah, I
believe.
know there is VLL. Yeah, but I think maybe we can keep that question until we discuss VPLS, and then we can now try to see the differences between VPLS and VPWS, if you don't mind.
Okay. No. Okay.
Okay, thank you. Any other question? Any? Okay, I assume we are all good. We are on the same page. So I move to the next slide where we are now focusing on the virtual private wire service. So this was the first type of L2VPN that we mentioned, and we are calling it the virtual. Remember, it's virtual, it's not physical. It's kind of logical connection that you are providing on your service provider network. So it's virtual and it's private, meaning that uh, the data is even transparent and it's not shared. There is no you cannot see the data that is being carried on that L2VPN as we've mentioned. And then it's a wire service. So many times, of course, there are many names. Different vendors will give them different names. On Huawei, primarily we call them the VPWS or virtual private wire service. There are those one who just generalized and call them pseudo wires. There are those one who will call them e-pipes. So it depends with the vendor, but again, they have the same working principle. It's just the naming that is different from different vendors. So when we look at the virtual private wire service, this is a layer 2 technology, and it's providing a point-to-point connections. So the keyword, it's providing point-to-point connection over an MPLS or IP network. So it's simulating the behavior of list line. A list line is a kind of, maybe you have an office in a given location and you have another office in another different location, and then you list, like you are deploying a fiber from point A to point B, and that fiber is dedicated only for your services. So that's what the virtual private wire service is doing. It's providing point-to-point connection, and it's simulating the behavior of list line. So list line, of course, these one are very expensive. If you request a list line, like you want to build a connection from point A to point B, it comes at a cost. It's not cheap. And if you are the one who are deploying that physical setup, then it means you need to take care of the fiber. If there are any issues on the fiber, you have to fix the issues on your own. But if you give that task to the service provider, it also comes at a cost, because list line are always expensive compared to the shared network. Because if we are deploying the L2VPN, the virtual private wire service on the shared network, the MPLS backbone, then it's relatively cheaper because we are sharing the cost across all the customers that we have on our network. So this one allows organization to connect geographically dispersed sites with a virtual connection that functions like a dedicated line, but over a shared network infrastructure. So from the customer's perspective, of course, for them, they see it as kind of a dedicated connection, because for you, you don't know how this customer network is. You don't know the kind of routers. You don't even care whether they are using Cisco, whether they are using Huawei, whether they are using Nokia or even ZTE. You don't care. And you don't even mind to learn about their network. No. You just need them to give you a connection. They dope a fiber, you connect to your equipment, they give you a layer 2 service, the virtual private wire service. You test the connectivity from your point A to point B, and that is it. Everything else now is up to you to configure the protocols. It's up to you to control the routing and all the other general tasks that comes with the network operations. So they provide a cost-effective and scalable alternative to traditional list lines, offering the benefits of a dedicated connection over the shared network infrastructure. So if you have assuming that you have an office in Nairobi and you have another office in London or in India or any country, Nigeria, South Africa, we will be deploying a dedicated connection over the existing network infrastructure for you to be able to connect to all these different offices. You cannot use the same L2VPN for you to connect to, if you are using, that is in case you are using the virtual private wire service. You cannot deploy just one VPWS or one pseudo wire for you to be able to connect between all these offices. No, we will be deploying one VPWS for the specific inter-site communications. If you want from Nairobi to Nigeria, we deploy for you a pseudo wire from Nairobi to Nigeria, and then we connect you the two offices. If you want communication to London, to India, we also provide one dedicated L2VPN for that connection. So these are the key features and benefits. It's a point-to-point connection. Remember, this one you cannot do point to multi-point kind of setups. So you only have point-to-point connection. You have, yes, someone has a question?
Yes, Martin.
Yes.
When you were speaking about VPWS acting as a leased line,
Yes.
but in a shared network. I mean,
Yes.
in a shared line, VPWS acts like a dedicated line.
Yes.
My concern was about the bandwidth.
Yes.
A dedicated line means a customer will be having enough bandwidth rather than
Yes.
in a shared network.
Yes.
Then right now you talked about when you need a connection maybe from Dar es Salaam, Tanzania to maybe Nairobi, Kenya,
Yes.
and other connection maybe from Tanzania to South Africa.
Yes.
They will need different VPWSs.
Yes.
Does this have any significance to the bandwidths, or what's the point of view on bandwidth in this VPWS?
Yes, okay. Anyone who can respond to that question if I come in?
Okay, good afternoon.
Yes, Fabian.
Yeah, that basically what customer is selling to you when he deploys either layer 2 VPN or layer 3 VPN for you is the bandwidth. So there's always a capping on your service that you cannot exceed. Otherwise, you take the whole resources of the service provider. So if you pay for 1 Mbps on this tunnel, if you want to take 1 Mbps of this tunnel, your traffic will be capped on the customer, on the ISP side, on the provider side, that for this circuit, you can only do 1 Mbps or 1 gig for either layer 2 VPN or layer 3 VPN. Those services are capped. So that is where the service provider makes his own money. Thank you.
Okay, thank you. Anyone else with another anything else to add?
Hello? So, Martin,
Yes, Aaron. Yes, Nixon. Who comes first?
okay, Nixon can come first. I was
Keep
just
going.
going to say something simple that I think the service provider will do some sort of like shaping or policing, like to put a policy about the and set a cap for what you can use, right? So beyond which you will definitely the customer will start experiencing some sort of degradation. But again, from the bandwidth perspective, the service provider must be the one to do the like to again be committing to what he can provide. Right? They cannot commit like we'll give like 2 Mbps when the link is now congested with other services and all that. So I think for bandwidth, the design will be on the service provider and they will apply some sort of policies that you use what is agreed as per the SLA.
Hello. So I think from my perspective,
Yes, yes.
enterprise services are always very small, minimal. When it's being routed, I mean, when it's going through the service provider network, mobile traffic is huge. So I don't think there will be more of a limitation on what you are providing because if you compare enterprise services, they are always very small compared to mobile services, and you are transporting their network over the mobile network, the service provider, which is service provider.
Okay. Anyone else? The last person. That's interesting.
Yeah, hello, Martin.
Yes, Monza.
Yes, I'm Munzi. Yeah, to briefly say what providers do is just a matter of what quality of service. I believe it's like traffic shaping exactly. So you see what customers wants exactly, and then you create a profile for it. Uh, so what I want to say is, you always have to check the resources that you have, so you don't suffer from bottleneck. Like sometimes you can provide a lot of uh, customers, a lot of bandwidth, and then you find that your backhaul is not enough for all of them. So it's matter of planning and quality of service.
Okay, that's true. Nixon, you had something to add before we.
Yeah, okay. So, in relation to bandwidth, for example, like I'm dealing with mobile service network, and in that relation, we have a specific amount of bandwidth that we usually request from our ISPs that actually deal with the fiber. So, in a case where we have like congestion, like when we are experiencing congestion due to exhaustion of bandwidths. We also request for, because for management, like we reach out to our provider and we request for an expansion and we pay for it because since our service or our bandwidth is getting limited due to high capacity, That means we are expanding and we need more capacity. So in order for us to keep our network very strong, reachable, and more this thing, we actually going for an additional bandwidth, which they will end up provide for us at the end of the day. So that's what I wanted to say.
Yeah, thank you all for your contributions. So, Innocent, I think you've got it right. You've got it clearly. Like, as a service provider, you always have to dimension your network. And if you know that you don't have capacity in this location, then you don't have to sell those. Like, you can control, you can choose whom you are selling to. You can choose when to provide services for them. And if you don't have enough capacity, it's always good not to go ahead and deploy services for them, because it will bring in degradation for other customers. So many times when a customer brings in a request, they want 10 MB, they want 50 MB. There are those one, especially for those one who are distributing net in different locations. They want 1 GB, they want 2 GB, some even want maybe 50 GB. You always have to check your network. Do I have the necessary resources? Do I have the capacity to provide this service to this customer? Because remember, you also have other services that are being carried on the network. You have 2G, 3G, 4G. So you need to dimension, you need to check what is the current capacity that I'm doing on this network. Can I accommodate this kind of traffic? And if it's not, then you need to do. So what I've seen common is you need to do capacity upgrades. Whenever you have new customers coming in and they are consuming more of your existing capacity or bandwidth, then you need to provision or to upgrade the capacity. You can do from 10G to 100G or 50G, depending on the requirement or the bandwidth prediction that you want. Because customers will come in any day, anytime. And once you've deployed them, as it was mentioned, you also need to do some limiting, because a customer will purchase 8 MB, but if you allow him or them, then they can push even 50 GB. And the limiting should be done at the point of connection. If that customer is connecting to a CSG somewhere, you need to apply traffic limiting or the policing at that point of connection, so that this traffic does not even traverse our network and consume the bandwidth that we have. So many times you need to factor in the available bandwidth of your network, either do capacity upgrades, and once you accept them, then you also need to do some policing, some limiting. If they have purchased 2 GB, just limit to that 2 GB. If they have purchased 5 MB, try and limit that customer to that 5 MB so that they don't consume the whole bandwidth that you have on the network. I hope that's clear. Okay, let's continue. So we mentioned that they are point-to-point connection. They are layer 2 service, which means they are operating at layer 2 and it's transparent. So the services are carried transparently across the service provider network. Then, of course, we need to deploy them on MPLS backbone. Like, before you deploy this VPWS, you must have the MPLS, you must have LDP, because you will need a signaling protocol. So we normally deploy them on MPLS or IP network infrastructure. So you must have these underlying protocols deployed on your network. Then it's kind of virtual list line. It provides user experience of a list line with the flexibility and cost advantages of a shared network. Reduced cost, of course, you are deploying services for different customers on the same existing network infrastructure. So that one helps to reduce the cost of connecting remote sites compared to when you are using the dedicated list lines. And finally, scalability. So they can also scale to accommodate growing bandwidth needs and new site connection. So of course, you can just do capacity upgrade of your network, and then you are able to accommodate more customers. You are able to deploy services for more customers on your network. So this is how it looks like for the L2VPN VPWS architecture. So you have on the IPRAN network, of course, this one could be the CSGs. It depends with your where your customer is connecting. It could be the ASG or it could be the RSG. It depends with the point of connection of that customer. That's what we call the provider edge. So when we discussed on MPLS, remember we mentioned about the provider edge, the provider, and then we have the customer edge. So you have customers in different locations, offices in different locations, and these customers, they want to connect their sites. They want to be able to communicate among the different sites in different regions, connecting to different PEs. So we normally have two types of architectures. We have what we call the local, like the local pseudo-wire. So in this case, you can see that you have a customer, and this customer is connecting to the same provider edge PE, but they are in different locations. It's not like this is the same office. No, these are different offices. Just that they are close to this PE, and you are able to provide kind of Ethernet or fiber connections to the customer. So if they are connected to the same PE, this one we call it a local connection. So when you are doing that L2VPN configurations, many times you just need to include the two connections in your VPWS configurations, because it's like just kind of a direct connection that you are providing for this customer, so that whenever services are coming from this side, they are able to be switched. And remember, with layer 2, of course, when a packet comes in, you send it to all
Hello,
the other.
Martins.
Yes,
Sorry,
yes, yes, yes.
I use maybe mouse. I think there's a lag from when you type and when you speak. Maybe you can use pointer, mouse pointer, as you are describing.
Okay. Okay, so I was mentioning about the local connection where you have two customers connecting to the same PE. So in that kind of setup, then you don't need to have like the tunnels. We don't need to establish tunnels because this customer is connecting to the same PE. And then we have what we call the remote connection. So remote connection, you have a customer connecting to I feel I may need to use the pen again. You have a customer. This customer is connecting to one PE in a given location. If I use a different color. So this customer has a connection to this PE. And then we have another office in a remote location. This remote location is connected to the provider edge in that remote location. So you see that in that kind of setup, we need to deploy the tunnel. So we will be having a remote tunnel, a tunnel that will be used to carry those services from this local PE to the remote PE. So in this case, we need to deploy a tunnel for us to be able to carry services from one customer site to another customer site. And depending on the number of connections, with the number of customers that you have, so each customer will have their own e-pipe or pseudo-wire or VPWS that will be deployed across the network so that it can be used to carry the services. So you can see that if we have a customer in this connecting on this PE, we also need to deploy a separate VPWS on the network. And this virtual private wire service will be used to carry the services only for this customer. So one pseudo wire per customer. So if you have so many customers, it means you will have so many pseudo wires on the network. And each pseudo wire will be responsible for carrying services for that specific customer. So these are the two types of connection that we expect when we talk about the VPWS layer 2 services. So how it works? Of course, layer 2 VPNs, we need to have signaling. And remember, this is MPLS VPN. So we also need to have labels assigned to be able to carry the services of the customer. So the signaling protocols that we can either use the label distribution protocol or the BGP, which will be used to establish and manage the point-to-point connection between the provider edge routers. We will be using MPLS labels that will be used to identify and forward traffic across the network between the two endpoints. We normally have what we call the virtual circuits. So a virtual circuit will be established between the two CEs, the customer edge, representing the virtual list line. And then for the traffic forwarding, it will be encapsulated with MPLS labels and forwarded based on the label switching path, or the LSP. So this one just creates a virtual connection over the existing interlay network. Some of the functional modules, you have the access circuit. So the access circuit, this is an independent physical or virtual circuit connecting a CE and the PE. So you have the customer device. Of course, you need to have some kind of connection from the customer CE device to the provider edge device. That's what we are calling the access circuit. Then we have the pseudo wire. This will be the virtual link. The virtual link or the virtual tunnel that we are, the virtual link that we are establishing from PE, from one PE to the remote PE. And then the tunnel, of course, this is also a virtual link that will be used to transparently transmit the service data. And then you need signaling for this pseudo wire. So remember, we've talked about LDP and BGP as the options that you can use for signaling. Now, these are some common use cases that you can use virtual private wire services on IPRAN network.
Martin,
Yes.
can you go back to the previous slide? One second. I'm sorry, but what is AC in full? Can you just remind me the access circuit? Okay.
Yeah.
All right.
Martin, is it access circuit or
Martin?
attached circuit?
There?
Is it access or attached circuit?
Oh, yes, the attached circuit, the attachment circuit, actually. You confused me
Okay.
with your access.
Martin?
Yes. The attachment
Yes,
circuit.
this is the attachment circuit,
Oh,
and I think virtual circuit is established between two PEs, not CEs.
yes. That's what I'm trying to equally point out.
Yes, I was also confusing.
Okay, so for the AC, yes, the correct name should be the attachment circuit. And the virtual circuit, yeah, you are right. It should be established between the P's. I will correct on this.
Okay.
Yeah. Anything else? Any other comment before we move to the next slide? So we have the virtual circuit and the attachment circuit. Yes?
So the question between, so how is the PW different from the tunnel? Maybe you can explain a bit more?
Anyone who can explain the difference between, you asked about the virtual circuit and the tunnel, right?
No, PW, the last,
the PW and
second.
the tunnel, okay?
Yes.
Anyone who can explain that?
Sorry, can you repeat the question again? I couldn't get the question.
He wants to get the difference between the PW and the tunnel. Like you can see in this topology, we have a tunnel from P1. Of course, the tunnel, you can see that it's being established from P1 to P. And then we have another tunnel from P to P2. And then now we have the pseudo wire. So he wants to get the difference between the pseudo wire and the tunnel.
Okay.
That was right.
I think the tunnel connects the two BEs together, but for the W, like the wire connect for a specific customer, but the tunnel can contain, for example, multiple customers from BE1 to BE2.
Yes, that's very true. So for the tunnel will be used to carry just the services for different customers from P1 to P2. But now for the pseudo wire, that one is specific to the customer. So it's identifying the traffic, and that pseudo wire, I mean the traffic from the customer. Of course, it has the attributes of that pseudo wire, but it will be carried on that tunnel, on the same tunnel. So traffic from different customers will be carried on the same tunnel, like it's a shared tunnel.
This one,
Okay.
Yes.
Okay. What about the?
Okay, keep going.
Okay. So okay. So I understood. That understood. Thank you very much. The PW signaling is for. Is this supposed to be for signaling before the actual PW for individual customer services being transported? Like a signaling before maybe like so I just want to know the PW for signaling is meant for what?
Maybe you're asking why we need signaling, right? Anyone who can respond to
Yes.
that?
That last
Monsa,
point,
I see
PW
you are,
signal.
or Nixon.
All right. Let me just add something here from my own understanding. That PW,
Yes.
that PW is a customer facing. It's like a virtual layer 2 connection that emulates a specific service. It could be Ethernet, and it's carried inside the tunnel.
Yes.
That's how it works. So, and when we talk about the tunnel, it's a provider transport mechanism. For example, it could be MPLS, LSP, or IP base that carries one or more PWs, other traffic between the network. That's how it normally works, based on my understanding.
Yeah, that's true. Monsa?
Yes, thank you. I just want to like to make something clear. Like when we're speaking about the LDB for layer 2 and the LDB for the tunnel itself. Like we can connect several BEs using LDB or using, for example, an RSVP to create tunnels between BEs. But then we can make the pseudo wire or the layer 2 thing that we want to apply over the tunnel itself. So basically, we need to connect the BEs, and then we can apply the layer 2 over them.
Yes,
I think I have
that's true.
explained this earlier. What I want to say about the signaling is just like establishing the sessions between them. This what I from my point of perspective when I speak about signaling is just like establishing sessions.
Yeah, establishing and maintaining the session.
Thank you.
Okay, I hope we are clear on that.
Yes.
Okay.
Can it be a control plane? Can we call it as a control plane?
Yes, actually the signaling happens at the control plane. So it's true. It's happening at the control plane. Hope that's clear, Leonard.
Oh, yes, 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 it's clear. Thank you.
Okay, okay. So let's shift to the remaining slides as we respond to the other questions. So we were looking at the use cases, and one of the use cases that we mentioned is for the enterprise services for remote customer. So this is, I believe this is straightforward. You have a customer in different locations. You deploy pseudo wires of VPWS for these different customers, and you connect them. So for them, it's like they are directly connected, or they have a kind of list direct connection from one office to the other. So for them, they are just assuming that yes, we are directly connected from point A to point B. But for you, you know that you have the shared infrastructure that is carrying these different customers. So you deploy a VPWS for different customers on your MPLS IP backbone network. So this is straightforward. I know we have deployed these services on our networks many times. If you've managed a service provider networks, you've definitely deployed these different types, different you have deployed a VPWS for different customers many times. These requests will always keep coming, and you need to be able to deploy the layer 2 services to connect different types of customers on your network. Another use case of VPWS is when you need to deploy protection links on IPRAN network in the same, this is in the same AS. So assuming that you have these two rings, you've assigned different IGP processes. You've assigned, for example, IGP process 1, you have assigned IGP process 2 in this other ring. Now, at this point, I've just used a symbol topology, of course, but on a real network, you will find complicated scenarios. But again, you need to be able to deploy the protection links for these services. So you can see that you have deployed one process here, and you have another process here.
Yeah, good afternoon.
Yes, yes. Someone has a question or a comment? Good afternoon to you. So when you have such a scenario, and I know this is a common application, especially for those who are managing service provider networks for especially the ISPs, the internet service providers. So you could be having this kind of a setup, and at this point, you see, at this point, we have a connection from the two rings. And unless you are able to provide like the multi area or multi-topology ISIS, then you need to find a way in which you can extend these, because one of the links is you can configure, you can configure sub interfaces and pass ISIS on those links, enable OSPF. But again, at this point, apart from just configuring that point to point and extending this service to this connection, if we had a kind of a connection between these two nodes, you can choose, like, what if I lose all these connections here? I've lost these two physical connections. This is just one physical connection between these two routers. And your ISIS was configured on these links. You use sub interfaces. Now you have a crisis. And your crisis is, what if you have another fiber that is disconnected at this point? Yes, these devices are connected. You see, these services can still flow through this side and come and terminate on this router. So what you can do, or most many times what we normally do is you can deploy a layer 2 service because you've already configured ISIS1 in this. You cannot go ahead and start changing this one to ISIS2 so that they are in the same ISIS. Or maybe you choose, let me go ahead and change these guys to ISIS1. That may not be the best solution because it will be time consuming. So what you can do is you can go ahead and deploy a layer 2 service. You pick it from here. Of course, this is the point of connection. You pick it from this point. You will deploy a layer 2 service up to this router, up to this point. Now, you've extended this ring through the other ring, and you can deploy your L3 on these points of connection. So you can deploy your L3, and then you will have the reachability through the ring, through the other ring, ring 1, which you have deployed ISIS1. We've had to do this in real network many times because fiber, you can never predict where the fiber cut will happen. Sometimes you've deployed your network, you've segmented into the rings, but these rings, they will always interconnect at some point because you are trying to improve the reliability of your network. So once you have such point of connections, then you can always consider to deploy a layer 2 service, and that layer 2 service will be used to protect this ring. So whenever you have multiple fiber cuts in this ring, you can still go ahead and have your services flow through the other ring, but you are not changing the IGP process of the other ring. You are just providing a layer 2 kind of connection on the boundary node so that you are able to carry the services on the other ring. I know we've all implemented this at some point if you've managed a service provider network. Any question before we move to the next use case?
So sorry, Martin, can you take this your Dixon again? Let me get the clear picture. I didn't get the clear picture.
Which one?
Can you take the clear picture of protecting this ring on an IPRAN from this your diagram?
A clear picture, like maybe you ask a specific
Hmm?
question, then it will be easy
Can
to.
can you re-explain how you said you protect this you protect this?
Okay, I've mentioned you have deployed your network, and once you've deployed your network, sometimes, of course, you've split the network into rings, right? You've deployed ring 1, ring 2, ring 3, but the way we have the connections, you will always find a connection between the two rings. So of course, you've gone ahead and deployed ISIS1 in ring 1, you've deployed ISIS2 in ring 2, or OSPF, or whichever protocol that you are using as IGP. Now, at this point, you've passed the two. Let me just discard this drawing so that at this point, you have two ISIS process running, right? You have ISIS1, you have ISIS2 running. And the worst case scenario happens. You've lost this connection. You've also lost this connection. Because we never know where the points, where the fiber cuts will happen in the network. It can happen from anywhere, at any point, at any time, because that's not predictable. So what happens when you lose this connection? It means the services for these guys will be down, right? Why? Because you've lost, you are like kind of isolated from ISIS process 1. And if you've deployed ISIS2 in these other rings, it means, of course, the routes from ISIS1 will not be shared to ISIS2. So an easy way to solve this issue is you can deploy a layer 2 VPN. You are deploying a layer 2 VPN across or over this ring 2 So you deploy L2VPN going all the way because you have a connection, assuming you have a connection at this point, because ASGs, it will find a way to connect to another ASG through some other connections. So you can deploy your L2VPN up to this point. This is the source, this is the sink, and you deploy your L3. So you configure IP addresses on those connections. Of course, you've deployed using a VLAN, so you configure your sub interfaces on these routers. And you go ahead to configure ISIS, like you activate ISIS1 on this L2 over this L2 service. And then if there were such an instance where you are having multiple fiber cuts, your services can still flow through the L2 service that we've deployed without any issue. And it's faster, it will be quicker compared to you starting to imagine, let me start changing the ISIS process of these routers to ISIS2. You have to delete that ISIS process, you have to configure it, activate it on the interfaces, and what happens when this link restores? You need to, again, start deleting ISIS2 and activating ISIS1 on the boxes. So you find it that it may not be efficient. It will take some time. I hope that's clear, unless there are any other questions. So that is just a scenario in the same autonomous system number, just that we have different IGP processes. Is that clear? Who had asked the question?
Yes. I think I've gotten what I was
Okay.
looking for. Thank you.
So sometimes we also have a scenario where you have a connection. Like, I know we all have these scenarios, like we have these types of connection in the network. So this is in different autonomous systems. You have a connection. This is, for example, this is S100. This is S200. Remember, if we have such kind of connection from S200 to S100, you cannot go ahead and start activating IGP on this link. Right? Because you've isolated these regions. Maybe these are two different regions, region 1, region 2. You've specified that in region 1 I'm using S200. In region 2 I'm using S100. If you have such kind of connections, which I'm sure we have in your networks, you cannot go ahead and start deploying IGP on that link. Because what happens if you are to lose these connections? Does it mean that you will leave these services down? The services in S200? Here we have only 4 sites. In a region, in a real application network, real live network, you will be having more than 300, 500, or even 1,000 sites. Does it mean now you will leave these guys to be down for the whole day until the fiber is restored? No. So what you do, you can still use L2VPN, VPWS. You can deploy pseudo wires. Remember, pseudo wires can go wherever you want them to go. So you deploy a layer 2 service across the S100, provided we have that kind of connection also. Then you are able to drop it here, and you are able to establish L3 interfaces on these 2 nodes. So you have another exit. You have another point of exit, but through the L2VPN that you've deployed in S100. So that is also another example where you can use L2VPNs, the VPWS or the pseudo wires, to achieve or to resolve connectivity issues in your network. I hope this is also clear and straightforward. Another use case, when you have remote sparse networks. So you have the IPRAN network. Remember, IPRAN spans the entire country. And then you have the IPCO. IPCO in different regions. And remember, the IPCO should also be connected. And maybe you don't have fiber that is running all the way from one IPCO site to another IPCO site. So what you can do is you can also go ahead and deploy L2 services that will help you to interconnect different IPCO sites using the L2VPNs. I know this is also a very common use case that we have in our networks. You are able to interconnect different IPCO sites through your IPRAN network using the pseudo wires or the L2VPNs. How do you configure L2VPNs? This one just gives a summary. So, of course, remember you need to configure the underlay. You also need to configure the overlay network. So you start, of course, by configuring IP address on interfaces. You need to configure IGP. It doesn't matter which kind of IGP you'll be deploying, whether OSPF, ISIS, EHRP, provided we have reachability between local and remote provider edge routers. That is all that we need. Then you configure MPLS, you configure LDP as the signaling protocol, or if you are configuring BGP as the signaling protocol, of course, you will still go ahead and configure BGP. You also need to activate MPLS, you need to activate L2VPN, you need to configure LDP on the interfaces. So this is very important. Don't start having trouble when you are troubleshooting and you've just forgotten that you did not activate MPLS on a given interface. Such issues you can troubleshoot all day without finding a solution. So you always have to ensure that in your MPLS backbone, you've activated MPLS and MPLS LDP and the L2VPN on the nodes in your IP MPLS backbone. If you have remote connections, if you have remote PE connection, like the customers are connecting to different nodes, then you need to configure LDP remote peers between the provider edge routers. And when you are doing the remote peerings, you just need to specify the loopback IP of the remote PE device on the local device. Then you are good to go. Your LDP sessions between the remote devices will be up. Once you've done that, you can now go ahead and configure pseudowire on the local and remote PEs. So the pseudowire configuration will be done on both nodes, both local and remote. And then you need to configure the service interfaces on the customer sites, and you can do service verification on your network. So you go ahead and test. Is ping okay? Am I able to run the routing protocol of my choice? If it's OSPF, is that OSPF okay? Is it up? So those are the things that you need to verify on your network. Drawbacks of VPWS: scalability, only meant for point-to-point. You cannot do point-to-multi-point connections. Resource intensive. Of course, this one comes in when you have so many customers. Remember, every customer you will have to deploy a separate pseudo wire on your service provider network. And you need to maintain the sessions. So if you have 1,000 customers, you have to configure 1,000 pseudo wires And this one, of course, consumes some network resources as much as we have advanced devices nowadays. Lack of advanced features, for example, limited load balancing. It has similar control plane, which of course can simplify the initial setup, but when you are troubleshooting, it becomes a big challenge. Management complexity. Normally, you can either do manual configurations. There's those one who don't have NMS like the NCE. Huawei, they have NCE, and other companies, of course, other vendors, they also have tools that you can use to deploy L2 services. But if you don't have those tools, then you need to do manual configurations. It's not easy. It's very easy when you are using tools like the NCE or maybe NFMP for Nokia. But if you are doing it manually and you are not experienced enough, or you haven't done it more often, then you may find yourself struggling to bring up the L2VPNs, the VPWS. Troubleshooting challenges. If you have a large VPWS network, it can be complex because you have so many connections. And sometimes you may have potential, like you have single points of failure in your network. So these are the drawbacks of VPWS, only supporting point-to-point connections. Any question before we shift to VPLS and then we finish with EVPN?
Hello, Martin.
Yes.
Is the VPWS still operational
Yes.
in the IPRAN network?
Yes, many of them. Thousands of them.
I thought it was just rejected.
No. Which one will you use, or which ones are you using in?
I thought just we are using VPLS most of the time for multi-point connection.
No. Well, actually, you can still use VPLS for point-to-point connection, but yeah, we still have the pseudo wires, the VPWS, on many of the production networks. We have them deployed.
Okay,
Unless
understand.
someone
Okay,
else
thank you.
has a contrary opinion, but for the networks I've worked for, we have them. Many, countless. Because that's
Okay.
how many times, that is how we normally deploy the services for the enterprise customers. Yes, Monsa, I see you, your hand is raised. Any comment, any addition? Monsa? Okay, if there is no any other question, then we shift to VPLS.
Hello, Martin.
Yes, Mosin.
Which subtypes comes under the VPWS, like cross connect circuit and L2VC?
Yes, all those that you've mentioned. We have the CCC, we have the VLL.
Okay.
So we have different variants.
Okay, thank you.
Any other question before we move to the next slide? So we've talked about VPWS, and a major drawback of VPWS it's on the ability to only support point-to-point connections. Nowadays we have offices, we have businesses with branches across the country, different regions. So you need to be able to accommodate such kinds of customers. You have a bank, this bank has branches across the country. You have a post office, they have branches across the country. You cannot do a kind of a meshed point-to-point connection where every office has a pseudo wire to another office. That one will be messy. So you need to find a way in which you can now use kind of point-to-point point to multi-point connection or point or multi-point to multi-point kind of setup. So that's where the VPLS, virtual private LAN service, comes in. So VPLS are very simple and easy architecture. It provides point to multi-point L2VPN connection service. So you can see that you have customer one. This customer one has offices in different regions. They have site 1, site 2, site 3, site 4. And as I've mentioned, if you are to deploy e-pipes or pseudo wires, it means from this guy, you need to deploy a pseudo wire to this PE. You also need a pseudo wire to this PE. You also need a pseudo wire to this PE for that specific service. If you want this one to communicate with the other customer, you will have a pseudo wire to this customer. You will also need a pseudo wire to this customer. If you want this PE, then it means you will have another pseudo wire. So you have a kind of a meshed kind of setup that will be used now to ensure that you have reachability or connectivity between these different customers. So that one will not use.
Martin,
Yes.
like layer 3 VPN, we can leak the routes. Can we also leak the information in L2 VPN, like a VPWS? We can
No, for
leak the information
VPLS
from.
and VPWS, you cannot do the leaking of the routes. But in
Oh, okay.
EVPN, remember EVPN still uses the route distinguisher and the route target, so you are able to
For
achieve that.
for layer 2 as well, right? If
Maybe
we
I
are
need to.
configuring EVPN,
Yes.
if we are configuring EVPN for layer 2 connectivity,
Yes.
can we leak the information?
Not sure. I may need to experiment that, or someone who
Okay.
has done that can comment.
Right.
Yeah,
Okay.
but I may need to verify so that I don't give
Okay.
false information. Anyone who has an idea whether we can do route leaking in EVPN L2VPN?
Hello.
Yes, Mohammed.
Yeah, I think it's possible in EVPN, but not in layer 2 VPLS or VPWS, because VPWS will not carry your routes, your customer routes.
Yes.
So why you want to leak the route? Why you want to leak? Because they are not carrying your routes, customer routes. So leaking is required where you want to some customer routes or some another customer leak between two customer or three customer. So there is no route. So why you want to ask about that? I think it's also not possible, and it's not required also in actual environment and ISP.
Yeah, that's very true. Remember, first we mentioned that with ePipe, you are not even able to see the routing information. Even with VPLS, you are only able to learn the MAC addresses on your service provider network, but you are not able to learn
Yeah.
the exact or the real routing information from the different customers. So you are not able to do route leaking, but with
Yeah.
EVPN, you should be able to do route leaking. For the EVPN,
And
again,
EVPN you can do it's
yes,
because your EVPN will carry the routes of each customer from one customer to another customer.
yes,
It's working like both layer 2 and layer 3.
layer
So
3,
there we can do, you can mention, because in EVPN you have RT, so you
yes,
can import and export, but
yes.
on layer 2 it's not possible. I think this is my experience, maybe I am wrong.
No. I agree with you. You are not wrong. Mohsin, I think that is okay.
Yes, that is clear.
Okay.
Thank you. Thank you, Mohammed.
So the VPLS working
Welcome.
principle. So with VPLS, we are simulating kind of a layer 2 Ethernet switch across a wide area network or the MAN. So for these customers, for them, they see this one as one big switch. Remember, with L2VPN, with VPWS, it was kind of a direct connection or a list line. But with VPLS, this one looks like a switch to the customer. And we are able to learn the MAC address from the customer side. So to the customer, they see this one as a switch. So they are like connected to a broadcast network. It's like a broadcast domain for the customer. Then from mentioned from the customer perspective, their geographically dispersed LANs are connected as if they were directly linked to a single switch. And with a switch, remember, that is a broadcast domain. The service provider's network will act as the backbone for the virtual switch. They will handle the forwarding of traffic between the customer site. And again, we need MPLS integration. The key features, VPLS will offer MAC address learning, so you are able to learn the MAC addresses. So that's why sometimes VPLS, it's easy to troubleshoot compared to the VPWS. Because if you are able to learn the customer MAC address on this device, then it shows the service is up and running. But for the ePipe or the pseudowire, you are not able to learn the MAC addresses on the provider edge devices. And then it provides point to multi-point connection. So these are the key features.
Martin,
Yes.
can you repeat this point again?
Which one?
About the MAC address learning.
Yes, with VPLS, remember, we mentioned that this one is acting as a switch, right? And if you have a connection on a switch, this switch is always able to do the MAC learning. When the packets are being sent from one source to the destination, it will be able to pick the source MAC address and store it in the MAC address table. So with VPLS, we are able to learn the MAC addresses because this is acting as a switch. So these PE routers, they will be having MAC addresses, especially when there is communication from one side to the other. Then they are able to pick the MAC address, the source MAC address from the packets. And then they will have a MAC address table for these customers. Hope that's clear.
Okay, thank you.
Okay, Martin, I have a question here.
Yes.
Please back one. Okay. For example, let's say customer one.
Yes.
When traffic sent from customer one
Yes.
to the P router, for the MAC address learning, we have three options. Yeah. The first, the destination MAC address it may be known or not. If the MAC address is known, the P router will just float the MAC address. Yeah.
Yes. So remember, it's acting like a switch, and it will use the same
Yeah.
mechanism of how a switch builds a MAC address table. So if the MAC address is not known, then it will be flooded, right?
So how can it float it? It is my question.
How can
because there are so many P router. Yeah.
How can it do what?
How can it float the MAC address? The P router will float the MAC address if the destination MAC address is all F. So how can it float? Because there are so many P and provider edge router and P routers.
Yes, it will flood it to it will flood it to those PEs for those for that are connected for that particular customers for that VPLS. It will broadcast it, except just like a switch, except the port. Maybe customer one wants to reach customer two, for instance, site two. So it will flood the PE. This PE directly connected to site one. We flood it to the network to all other PEs except the port it received it. That's the basic way it works.
So this is the main disadvantage. If you are deploying a VPLS in your whole network, there will be a heavy broadcast in your network. That's why people are preferring layer 3 VPN. That's why mostly SP are using layer 3.
Yes, there's a large broadcast on the network, and that's why people are running away. And that is the need to use layer 3 VPN and also EVPN coming in. Because
Yeah.
in EVPN, such brokers does not happen to take all the resources on your network.
Mostly ISP are using layer 2 for very little site, not whole. Now, mostly advanced ISP using layer 3, but some special customer they are using VPLS, not for all. It's due to broadcast issue, and that's also
Yeah,
explains.
still we are facing the still we are facing the network congestion, if we use
Yeah, definitely
VPLS.
it will be a network congestion.
Yeah.
Okay, okay, understand. Okay, thank you. Got it.
Okay. Any other question before we move to the next slide? Okay, thank you for the...
Hello, Martin.
Yes.
Hello, Martin.
Yes.
So why is the concept of VSI used in all this VSI? VSI, if you
VSI,
are
that is
configuring doing
a
your
virtual switching instance, right? So actually, when you are
yes.
creating your VPLS, you will be creating VSIs on these nodes. The virtual
Okay,
switch
or not the
instance.
note, not the piece.
Yes?
Okay, or not the piece, or not the piece, right? In this
Yes.
scenario.
Yeah. So you will be creating virtual switching instance, the VSIs, on these PE nodes.
Okay, thank you.
Someone else had a question or a comment before we move on to the next slide? So we've already discussed the working principle. We just went back to the topology again. But when we look at the advantages of VPLS, so you can see that flexible and rapid service deployment, we are using Ethernet interfaces on the user side, making it easy to deploy and provision services. Simplified network management, VPLS will enable users to control and maintain their routing policies within their own networks. We are also not controlling the routing policies of the customer network, no. As much as we are able to learn the MAC addresses, for the routing information, it's still maintained by the customer. So it's transparent still. Cost effectiveness, of course, we are building VPLS on the existing MPLS network. We are not deploying a specific network or different networks to be able to carry the services for different customers. We have high speed and performance, because remember, if you have high capacity links on your network, again, VPLS will be running on these existing networks, so it can inherit the high speed and performance features of your network. LAN emulation, we've mentioned that this one is kind of, we are connecting the LAN networks from different regions, and we are making it look like it's just connected to one switch. With VPLS, we are able to do MAC learning and forwarding. Again, it supports various access technologies, for example, Q1Q and .1Q, providing flexibility in network design, improved network efficiency, and low OPEX. We look at the drawbacks of VPLS, scalability issues. So it can become challenging to scale as the number of sites and MAC address increase. You've talked about the broadcast storms in the network. So if you have these MAC addresses being flooded across the entire network, it becomes a big challenge. MAC address management. Again, if you are just learning the MAC address, you cannot do things like summarization, like the same way we do for the IP addressing. Customer responsibility, of course, the customers are in charge of their own network configurations. Of course, sometimes they will still blame you for their issues, but yeah, you are a network engineer, you should be blamed whenever something is not working. Potential for loops, limited load balancing, especially for multi-home scenarios. and sometimes it's very hard to establish the issue or the RCA whenever there is an issue with your VPLS network. So you need to be familiar with Ethernet and MPLS working principles, and then you can go ahead to troubleshoot things like VPLS. If you are not familiar with them, then it becomes a challenge. VPLS configuration, almost similar with the VPWS configuration. Again, you need to configure the underlying network. You need to configure the IP address on interfaces. You need to configure IGP. Remember, we still need reachability between the different nodes. You need to configure MPLS and LDP. You need to configure, remember, of course, VPLS, you can still go ahead and use BGP as a signaling protocol. So you will still have to configure BGP if you are using BGP as the signaling protocols. You need to configure remote peers. You go ahead and configure the virtual switch instances, the VSIs on the PEs. You need to set the signaling protocol, either LDP or BGP, and then you need to bind the VSI to the attachment circuits connecting the customer sites. Once you've done that, you configure the service interfaces on the customer sites, and finally you can verify the services. You do ping tests, you check your MAC address tables on these provider edge devices, you confirm that you are able to learn the MAC addresses. That is it for the verification. This just summarizes the differences between VPLS and VPWS. So for the topology, VPLS supports point to multipoint or multipoint to multipoint kind of connection. VPWS only supports point to point connections. For the MAC learning, in VPLS we are learning MAC addresses. In VPWS we don't have MAC learning. Connection type, in VPLS we emulate a LAN. We are kind of connected to a switch. For VPWS we are emulating a list line. Scalability, VPLS, of course, it's more scalable compared to VPWS. Remember, if you have to configure VPWS for the meshed connections, it may not be scalable, especially if you have so many sites that want to communicate with each other. Use cases, connecting multiple branch offices, creating a virtual private LAN. When we look at VPWS, we've already talked about some specific usage scenarios that you can use VPWS. Finally, we need to quickly discuss about EVPN, the Ethernet VPN. So this is the technology, this is the new technology in the VPN domain. And so we call it the EVPN or the Ethernet VPN. So we are extending layer 2 Ethernet connectivity across a wide area network using the virtual private network. And this one, it allows businesses to securely connect multiple sites such as headquarters, branch offices, data centers. A very good application for EVPN, especially with the EVPN VXLAN. How it works. Again, we've talked about MPLS or VXLAN. So EVPN can be implemented using technologies like MPLS or the virtual extensible LAN or the VXLAN to encapsulate and transport Ethernet frames over the WAN. So VXLAN especially in the data center environment, but MPLS especially on the service provider network, just the normal service provider network. For example, the ISP, the IPRAN, you can use EVPN MPLS. But in the data center environment, majority it's on the EVPN VXLAN. EVPN, it will be using the BGP control plane for its control plane, and it will be responsible for advertising MAC address and routes between different network locations. So we are able to advertise both MAC addresses and the routes. Then we have unified architecture. It provides a unified architecture for both control and data planes, which simplifies management and enhance scalability of the network. The key benefits: secure and private connections, simplified network management. These are straightforward, so I may not discuss them in detail. Scalability and flexibility, cost effectiveness, and support for various services. So remember, EVPN, you can deploy both L2VPN and L3VPNs, and you can do more with EVPN compared to VPWS and VPLS. And again, one of the best application, of course, it's with the multi-homing. So you can have both active kind of multi-homed links, which is a bigger challenge when you have VPLS. Unless you do other kind of special configurations, you may not be able to achieve the active kind of setup. So it means one link will always remain to be backup. But with EVPN, you are able to achieve the active setup. The power of EVPN comes with the EVPN route types.
Sorry.
Yes, Mohammed.
Just I am disturbing you. Can you explain more, like how we can achieve multi-homing through EVPN and why we cannot achieve through layer 2 VPN, like VPLS? Can you explain like how?
Okay. So,
Like example.
yes, with VPLS, you know that VPLS, it's acting like a switch, right? So if you have these two guys, I need to draw. Let me just go back. I don't know whether I'm able to clear this. Let me discard. Or anyone who wants to give it a try before I draw my topologies. Anyone who wants to give it a try, how we can achieve multi-homing active in EVPN and not in VPLS. So you have a connection here. This connection is connected to two PEs. This is for VPLS. With this kind of setup, we know that this one is acting like a switch, right?
Yes.
If it's acting as a switch, assuming that we don't deploy things like STP, we will have loops in the network, right?
Yes.
If we deploy STP, it means some of the ports will be blocked, right?
Yeah.
Yeah, so if we are blocking some ports, either we can deploy like STP to ensure that we don't have loops, or we can manually shut down this interface so that we avoid. Remember, with the kind of setup, if we send this packet here, this packet will be sent across the network, then it will create a loop on this network if we were to have all these links working and active. So if you deploy STP, STP will have to block a link and make it a backup link, and it can only be active when the other link is down, then it can be restored, or you can manually shut it down to avoid loops on there, because remember, this one is acting as a switch, which means there is flooding of packets, or there is the broadcast domain. So this is with VPLS. With EVPN, you have a connection. This connection is connecting to two PEs. With two PEs, of course, this one I feel we should discuss first about the route types of EVPN, then maybe it will be clear. Because we have a
Okay.
specific type of a route that achieves this active multi-homing.
Okay, okay, okay.
Yeah, so
Got it.
just, yes.
Thank you. Now it's morally clear.
Okay. So EVPN, I mentioned that the power, what makes EVPN to be the best solution or to be preferred is due to the different route types that it supports. So these different route types will be performing some specific functions on the network, ensuring that, for example, we need a designated forwarder in the network. Well, there will be one specific route for that. We need to learn the MAC addresses and IP addresses. There will be a specific route for that. So we have different types of EVPN routes, and you need to, of course, I may not go deep into the contents of the different types of EVPN routes, but I will mention them so that you can study about them later. You can do some packet captures and try to see what information is carried on these type of routes and when are they exchanged between the remote and local PEs, or in case of a multi-homed PE, which route will be used to ensure that we control loops, we can have active kind of setup. So EVPN could be another separate topic on its own. It's a very wide topic. So just allow me to mention the different route types, and then we can explore it further, especially if we get a chance to do a lab simulation on the same. Then we can go deep into the details of these different route types. So commonly we have 5 types of routes. We have what we call the type 1, type 2, type 3, type 4, and type 5 routes. Those are the 5 most common types of routes types in EVPN. So type 1, we call it the Ethernet Auto Discovery, the AD route. And this Ethernet Auto Discovery route, it's the one that will be used for multi-homing scenarios and ensuring that there is load balancing in EVPN networks. So it will be used to discover the Ethernet segments. What is an Ethernet segment? If you have your CE here, and this CE it's connecting to 2 PEs, this one will be our Ethernet segment. So type 1 routes will be used to discover these Ethernet segments and their associated EVPN instances. So when we started, we mentioned about ESI. So when you are configuring this ESI, it's Ethernet segment identifier. For a multi-homed CEs, when you configure the ESI on this PE and this PE, you will configure the same ESI, because that's a multi-homed CE. So you configure the same Ethernet segment identifier. For a single homed CE, the ESI will be null. But yeah, you can correct me if I'm wrong. But from my initial understanding is for a single homed CE, the ESI will always be null. But for a multi-homed CE, they will come with ESI, and this ESI value will be the same. So you are able to identify that I'm connected, this PE and this PE, they are able to realize that yes, we are connected to the same customer edge device. And when you have a multi-home scenarios, you need what we call the designated forwarder. Designated forwarder is when you have the BAM traffic, like you have some broadcast traffic that is coming in. Remember, this CE is connected to these 2 PEs. If you don't elect the DF or the designated forwarder, it means this CE will be getting 2 copies of that broadcast or that multicast traffic, which should not be the case. So we need what we call the designated forwarder to ensure that we have only one guy or one PE that is in charge of forwarding the BAM traffic, broadcast, multicast, and unknown unicast traffic, so that we are not sending same copies of data to this customer edge. So we have two types, of course. The routes can be advertised per EVI, which is Ethernet Virtual Instance, or per ESI, which is Ethernet Segment Identifier. So you can explore these in detail. Again, this is a very long topic on its own. So the key aspects of Ethernet auto discovery. This is the route that is used for multi-homing. So if you are able to perform multi-homing, it means you are able to have two connections, and you can be able to load balance traffic so that you don't have just an idle link sitting there without any function. We've talked about the Ethernet segment identifier and the Ethernet virtual instance, the EVI.
Sorry.
Yes.
You talk about designated forwarder. It's selection based on what, like who will be RDF, and on both P.
Yeah, that is also another, maybe, unless I write it down and share in the group, because it's another process on its own. But someone
Because
can.
this is a new technology. Mostly 90% ISP deploy it now.
Yes.
EVPN, a service section EVPN. We want to learn this.
Yes.
We need this. Sorry. I'm just asking about this. Maybe it will take time more for clearance, but no issue. You can continue.
Yes, we can still, if we have time, we can still just have a separate session for EVPN.
Yeah, you need to. It will be best, and we will be given a thanks to you if you provide another session on EVPN, VXLAN,
Yeah.
like combine VPN, EVXLAN plus eServiceX. We need a
Yeah.
both session. I think it will be very helpful, and we will be kind for you if you provide this two session.
Okay, no problem.
Thank you.
I've noted it down.
Sorry, including MLAG.
MLAG, the challenge with MLAG, we can talk about the theory, yes, but I've had a challenge with ENSP to implement MLAG on ENSP.
Maybe you can try Huawei online free lab. Maybe you will find there for MLAG.
You've come across a free lab on Huawei. Maybe guys from Huawei can give us ideas on how to go about it. Because I know there is the new ENSP, the Pro, but that one you cannot access it from outside. You need to have an ID, an email kind of authentication that you should perform before you are able to log in and do your lab simulations. But I'll see what I can do on that.
Thank you.
So you have the multi-homed, and sometimes we've mentioned that again you could be having the single-homed. So this type 1 route also helps to improve on fast convergence of the network. I've mentioned about load balancing. We have aliasing, and then we have MAC address withdrawal. So when there is a change in the network, of course, you need to withdraw the MAC address. Remember, we have been exchanging the MAC address on this network. So you need to withdraw the MAC addresses again and say that, yes, this link has gone down. I cannot forward the traffic. So please withdraw the MAC address that is associated with this customer. So such kind of things. But again, maybe not in details, but we will revisit these things in the upcoming sessions. Let's look at type 2. So type 2, we've mentioned that we have the MAC IP advertisement. This is the route that will be in charge of advertising the MAC addresses and IP addresses on the network. The key aspect, MAC address advertisement between the local and the remote PEs. Again, if you are implementing IP address advertisement, then it will be used for that purpose, and then control plane learning. So the MAC addresses needs to be learned through the control plane. This is the type 2 MAC IP advertisement route. We have type 3, we call it the inclusive multicast Ethernet tag route. So whenever you have the BAM traffic, whenever you have a broadcast, a non-unicast and multicast traffic, how do you ensure that if you are having a multi-homed setup, you will not be sending copies of the same data to the CE? So this is where the inclusive multicast Ethernet tag route comes in, to ensure that we are able to forward the BAM traffic within the EVPN domain. We have type 4 Ethernet segment route. It will be used to discover multi-homed Ethernet segments. The Ethernet segment route. It will be used to discover the Ethernet segments. Again, it will be used for, it will also help in the DF election, the designated forward election for a given Ethernet segment. It will be responsible for forwarding bridge domain or layer 2 multicast traffic to and from multi-homed sites. So the election of a DF will ensure that only one device manages the responsibility of forwarding the BAM traffic, avoiding broadcasting.
Pardon?
Yes.
Sorry. What is the procedure to select designated forwarder?
Yeah,
how it is
that
selected?
that has been asked before. When we
Okay.
discuss about Ethernet segment in EVPN in
Okay.
detail, we will be, because it's a procedure. These PEs, they will exchange some packets and they will exchange some information, some attributes. And these attributes will be used to elect who becomes the DF. So we can discuss about that in another separate session.
I
So
think
this
there
is
is
for the type,
no.
yes. Yes,
I
Mohammed.
think there is no. There is any difference between type 1 and type 4. Both are used for multi-homing DF election. So, can you do you have
For the
any
type 1, we call
difference?
it the Ethernet auto discovery.
But this also used for multi-homing for DF election.
Yes,
And
actually in EVPN, these two types of routes, they perform almost similar functionality, but yeah, again, I will
maybe there is
request to. I know there are
no
so
issue,
many
no issue.
questions. These are new technology. We haven't interacted with it maybe more often, like the VPLS and VPWS. But I will organize a separate session where we can now dive deep into the operations of EVPN, so that we get to understand it
Yeah,
clearly.
yeah. Thank you.
Yeah, I know there are many questions
Sorry.
about. Yes.
No, at the start, it was easy, but the end, it's a complex. At the end, you put a complex topic. So this complex type need a lot of time. Not at the
Yes,
start.
yes.
At the start, you take more time. I think at the start,
Yeah,
maybe
there is
some
also.
people.
I think
Yes, yes.
I think this topic should be in other side in other training.
Yeah,
In
yeah,
other,
yeah. There
Yeah,
will
I
be another.
agree. I agree. That's why I
session.
mentioned that. Let's just mention about it. At least you should have an idea that yes, EVPN has
Yeah,
these types of
definitely.
routes. Then with
Yeah,
time
some
we'll
basic
build on
theory.
it. But at least you will be having a rough idea of all these terminology, so that we are again not starting from scratch. Okay.
Okay.
So that is the Ethernet segment route. And then finally we have type 5. So type 5, we call it the IP prefix routes. So this is the one that will be now, the primary role is to ensure that we are able to interchange or exchange the layer 3 routing information, the IP prefixes across the network. So it will be in charge of advertising IP prefixes, ensuring that we have efficient layer 3 routing. Again, it can be used in EVPN VXLAN, and it can also be used to ensure that we have inter-subnet routing across the EVPN network. That is type 5. EVPN configuration tasks. So this one talks about just the common EVPN, like the EVPN MPLS kind of deployment. But when you deploy other types of EVPN like the VXLAN or the variant versions of EVPN, you will have some different steps. But just to mention them again, you need to configure IGP on the backbone network to ensure connectivity. You need to configure MPLS, LDP, or TE tunnels on the backbone. Sometimes if you are using BGP, then you will have to, of course, this one depends on BGP. So you will have to configure BGP in step 7. And you also need to enable the EVPN family under the BGP configurations. You need to configure the layer 2 connections between the CEs and PEs. You need to configure an EVPN instance on each PE and bind the EVPN instance on each PE to the interface that connects the PE to site. You need to configure EVPN source addresses to identify the PEs in the EVPN networking. You need to configure ESIs, the Ethernet segment identifiers for the PEs connecting to the CEs. You need to configure BGP, I've mentioned that. And for it to scale, remember with BGP, you can introduce route reflectors. So you introduce route reflectors and then you are able to minimize the number of EVPN peering relationship required on your network. The same way we have route reflectors in the normal BGP network, you can also go ahead and introduce EVPN. I mean RR in EVPN network. Okay, I'm open to some few questions before we end the session. I've taken notes on the request for EVPN. We will prepare for that and then we can have separate sessions to discuss EVPN in details. But at least you know now that yes, there is some work to be done on EVPN.
Yeah. Really. I think EVPN as a mix of layer 2, EVPN will be work for both. For like it will be work for both layer 2 and layer 3 both.
Yes.
So if you are deploying EVPN, no need of layer 3 VPN, no need of layer 2 VPN. Maybe.
Yes.
So it's like a mix. It will be advertise your MAC address. It will be advertise your IP addresses, IP prefix. So it will
Yes.
work for both.
True. Any
Thank
questions
you
apart from
for
the
your.
EVPN
Thank you.
questions? Or any comment?
We really appreciate your work. You have prepared very well each and everything. And we have explained very well from the start.
Until the end.
No issue. I know.
Yeah, I know. The last we did it in the. Of course, we had little time for EVPN, but I'm sure we will get time and now discuss it in multiple sessions. We can't do it in one session, so we can split it into different sessions and then we can discuss about it.
Yeah. It's EVPN. It will be more clear if you are deploying on a lab. So if you checking in a practical environment, it will be more clear.
Yes.
Hello, Martins.
Yes, Alain.
So about the DF and
Yes.
the DSI, so you mentioned that the ESI are supposed to be the same on the two router, right?
Yes.
The ESI, and you talk about one being primary and one being secondary for the. But you also mentioned something around both of them being active, or maybe a kind of traffic being sent to both. So I'm trying to understand when you are doing multi or when you have one being selected as primary, um, that means one will be like the active and taking traffic while the other will be a standby.
Yes.
But I think you also mentioned something like a kind of load sharing in between. So can you just explain a bit more about either you are considering them to share on both. And also for the ESI, does it mean in this scenario, does it mean the C that is connected to them will see both of them as one? Because both of them are having the same ESI.
Yes.
Okay. So
Okay.
maybe, do you understand? Okay.
I will answer from the first question. So for the question about the active backup, of course, it depends with the kind of request that you have from the customer. If it requires active backup, then you see it's very easy. It's very easy to implement. You can even use, of course, things like VPLS will be active backup. But when you want to do active, then of course majorly will go with EVPN. The issue of the DF or the designated forwarder, the primary function is when you are forwarding the BAM traffic. Remember, you have a broadcast packet. You know that if in application network you have a broadcast traffic, you receive it, you have to flood it, right? You have to broadcast it to all other guys in the network. And if this one PE is receiving the BAM traffic, the other PE is also receiving the similar BAM traffic. And this traffic has to be flooded to the CE. So to avoid that scenario where both PEs are flooding this traffic to the CE, because why are we sending two copies of the same data to the CE? We don't have to, right? So that's where the DF, the designated forwarder, comes in, just to ensure that we have one PE that is designated to forward the BAM traffic, broadcast and non-unicast and multicast traffic. And that one avoids the issue of sending multiple copies of data to the CE from the two PEs that are multi-home to the single CE. Is that clear?
Okay, yes. Thank you.
Thank you, Martin.
Okay, thank you.
Appreciate it.
Any other last question before we close? Yes? Yes, Monsa? Anyone else has a question? Or a comment or a request before we end the session? Okay, thank you guys again for joining the session. I will be sharing the recording for the session and it will be uploaded on the Life Technologies YouTube channel. Just remember to also share the recording with your connections, with your colleagues. And yeah, we appreciate your support and your time to join this session. Thank you so much. And yeah, see you in the next session. Maybe it could be in EVPN, it could be in some lab for the enterprise services, but we will communicate once we are ready. Thank you so much. And
Thank you. Thank you, Martin.
thank you. Have a good evening or a good night for
Thank you.
this one who it's already a night. Thanks guys. Thank you. Thank you for your time.